Okay, so you have a terrain. What you need next is a mesh, and we're going to spend most of tomorrow talking about meshing because there's just a lot of nuance and power that you can unleash. But we want you to be able to build a model by the end of the day, so you need enough meshing background to be able to build a model. So that could be the name of this talk, enough meshing background to build a model. The basic idea is that your mesh has two parts. Your mesh has what we call a conceptual mesh and a computational mesh, and you only get to touch one of them, all right? You only get to touch the conceptual mesh. And so the conceptual mesh it's essentially a wire frame. I like to think of it as a trellis, all right? So like imagine that you've got a garden, right? And you're building a trellis, and then the plants grow around the trellis, and you're not like moving the plants like they're little nodes in the world. The plants get to do their own thing. You build the trellis that they respond to. That's the basic idea, is that you're going to build the trellis, you're going to build the wire frame, that the mesh is then going to follow repeatable, regular, algorithmic rules to generate. What does that mean? Well, first of all, that means that every time you press compute mesh on any machine with this conceptual frame, you're going to get the same mesh. Which means when you send me a mesh, what is the first thing that I say to you? Oh, your mesh doesn't reproduce on my machine. I can't even get started troubleshooting your model. This mesh will reproduce on every machine and always give you the same thing. Now, if you're feeling anxiety, I was just talking to Aaron in the back. I know Aaron's not feeling anxiety because he said to me, if I don't ever want to move another node in my whole entire life. I wasn't feeling that way at the beginning. I was like, hold on, moving little nodes is how I make things work, right? Like that's RAS. Well, like what is RAS other than moving your nodes, right? And I went in and I talked to Alex Kennedy about that. I was like, dude, the engineers are going to revolt. And he was like, stay with us. Like, give it some time. And now I'm with Aaron. I haven't made a mesh in 18 months because I don't ever want to move another node in my entire life. Partially because I want to give the mesh to other people, but part of it is that like I have never received a mesh from someone else that I liked. No offense, but yeah. But I want to do something different. But if you've moved 3 nodes, I have to start over. Right? Now I can get a mesh and be like, I don't really like the way they did that. And I can add a feature and redo the mesh without losing all the work that the previous mesher did. And so it's more transferable, it's more repeatable, and it's lighter. This, I'm going to give you a mesh on Thursday that's 200 megs. It's a 200 meg mesh. The wire frame is like 1. It's tiny, and so we can send our geometries back and forth. We can email our geometries if we want to, and now with the new file format, you can just like put that in your geometry folder, and it will automatically populate. This is all just a game changer. This is all just totally different. So you will not be editing your mesh. This is like a conceptual framework that has all the algorithmic rules that you need in order to build your mesh. You, however, are building a trellis. And then the mesh will form according to organic algorithmic rules around your trellis. And if you want a different mesh, you will build a different trellis. Your conceptual mesh has 3 components. If you think of, again, with the trellis analogy, it's like you've got nails, you've got boards, and then you've got sections, right? And so you've got 3 components. You've got arcs, which is your primary component. You're building this trellis out of arcs. The arcs come together at nodes. And when you have enough arcs that they encapsulate an area, it becomes automatically, topologically, remember spaghetti versus topology, topologically, Zach and Alex recognize that it's a region. And now a region is something that can be meshed. Okay, so here are some words that we're not using anymore. Perimeter, break line. Break line's my favorite word. You can't make a mesh without a break line. Who's going to make a mesh without a break line? What do? Your arc becomes your break line. And so your arc is your perimeter and your break line. Your node is where they intersect, and then your region is, essentially your area, or what's inside your perimeter, which means that your region can be a single arc with one node. It can be kind of self-enclosing, or it could be several arcs, preferably four, for reasons that will become apparent, that are connected with nodes. But both of these are regions that you can now mesh. So once you have a region, Zach will show you the quick edit picker, but you have four different mesh possibilities. You can have Cartesian, which is an old school vibe with a new twist, kind of literally. You can do triangles, you can do empty, or you can do what we call quads, which are aligned with flow. You're going to get tons of information about this tomorrow, so I'm not going to steal that information. But the basic idea here is, what is the primary challenge with meshing in a channel in RAS6? Aligning your cells with the channel flow, because you're going to be much more stable and you're going to be much more computationally efficient if your cells are aligned with flow. And if you're using the Cartesian mesh in 6, what's the only way to do that? Break lines that clip to areas, right? But then around bends, you're going to get that fan effect, which everyone loves the fan effect, right? Quads change the game. If all RAS2025 did was quads, I would still be solely in there, because the quads will align with the channel. And so the basic approach is you're going to use these quadrilaterals, quads, in the channel, and then in the overbanks, you'll use the Cartesian mesh or triangles, or sometimes you just put quads there too. And that's the basic idea. Way more on this tomorrow, but again, this lecture is everything you need to know to build a model. Okay, so what happened to our break lines? If you build meshes at all, break lines are your lifeline, essentially. Well, arcs don't actually have to connect with other arcs. Arcs don't have to form regions. You can have an arc in the middle of your region, and so this right here, it becomes a break line. Why are break lines so important? It's one word, it begins with S. It's the most important word in RAS computations.
Stability.
I love it. It's wrong, but I love it. Subgrid. What is subgrid? Why is subgrid so important? Well, this cell is a cell, fine. That's not what makes RAS so powerful. What makes RAS so powerful is that we actually know the volume elevation relationship within the cell. We have information on the subgrid scale. We know what's going on at a scale smaller than the cell itself, which means you can use much bigger cells, which means that's probably way too many cells. But we also know what's going on at the cell face. Each of these cell faces is a cross-section, which means that that's a cross-section which follows high ground. You want to make sure that your cell faces follow high ground. That's why we use break lines to align our cell faces with high ground, because of the magic of subgrid. So you can use arcs just like you would use break lines. And then we will mesh around them, and the arcs themselves can have properties. Remember, these arcs are still part of your trellis. This arc has its own meshing information. So in this case, we want more meshing detail around the arc, and so you can have a smaller cell spacing that will then transition to a larger cell spacing. You can also have what we call hanging arcs, and a hanging arc is really just a break line that connects to your region, but only connects to your region on one end. You're actually not just building a trellis. The trellis is data rich. And so you're building a trellis, but you're also giving it lots of information about how to mesh. And then, when everything's said and done, maybe you still don't like your mesh. Maybe there are still things about your mesh that you're like, man, I wish that was different. I wish there were fewer triangles. I wish there was more rectangles, but I just can't get that to work out. Well, this is where what we call post-processing comes in. Here you actually get to apply additional algorithms that are still repeatable, but will go in and move some nodes around for you based on some rules that you asked for. How do you know what to do if you're not Alex Sanchez? That's a question I ask myself a lot. Yeah, he's right next to me, so I go ask Alex Sanchez. But what we're doing, and Jacob's been involved in this, is we're pulling together commonly used post-processing tools as what we call recipes. I really like that. It's a recipe that now you can cook with. And the way I like to think about this, back to our trellis analogy, is okay, you've built a trellis, and the mesh is growing organically around it, but then you get to do a little pruning. Right. You're not going to move where the plants are going, but if you don't really love the way the way they're spreading out, you can do a little pruning with the post-processing. Okay, that is a very basic overview of the new meshing paradigm. We're going to go deep into it tomorrow, but we wanted to make sure that you kind of understood the basic components before we actually unleashed you to try it for the first time.